Mathematics Level 4, Topic 2, Module 1. Welcome to Topic 2 of the Mathematics Level 4 Support Package, Functions and Algebra. Module 1, Session 1. Module 1. Session 1 will cover Introduction to Topic 2, Subject Outcomes for Topic 2, Pre-Knowledge and Approach to Topic 2, Learning Outcome 2.1.1, Use and apply the factor and remainder theorem. Introduction to Topic 2, Functions and Algebra. We are going to spend the next 6 modules, or 2 days, working through the 5 subject outcomes of Topic 2, Functions and Algebra. Topic 2 is a huge part of the curriculum. If we turn to page 5 of the subject guidelines, we can see that it takes up 40 teaching hours of the year and has an overall weighting of 40%. Most of Paper 1 consists of the Functions and Algebra subject outcome. Topic 2, Subject Outcomes. Let's take a look at the 5 subject outcomes for Topic 2 on pages 5 to 8 of your subject guidelines. Subject Outcome 2.1. Work with algebraic expressions using the factor and remainder theorem. Subject Outcome 2.2. Use a variety of techniques to sketch and interpret graphs of the inverse of a function. Subject Outcome 2.3. Use mathematical models to investigate linear programming models. Subject Outcome 2.4. Investigate and use instantaneous rates of change of a variable when interpreting models both in mathematical and real-life situations. Subject Outcome 2.5. Analyze and represent mathematical and contextual situations using integrals and finding areas under curves by using integration rules. At Level 4, Topic 2 contains some completely new sections. The remainder and factor theorem is a completely new section. Finding and sketching the inverses of certain functions is also new. And finally, integration is another brand new section at this level. Linear programming and rates of change from Level 3 will be expanded on in Level 4. Pre-knowledge and approach for Topic 2. Let's start off Topic 2 with an activity. Please work in small groups and make notes in your workbooks during the group discussion. Discuss in your groups and report back. What pre-knowledge is essential for students beginning Topic 2 at Level 4? In your experience, what are students' main problem areas in Topic 2? What approach to Topic 2 have you found to be most useful? Where should we begin teaching Topic 2? If in any doubt, we can simply follow the order of the subject outcomes. The remainder and factor theorem need to be done before the section on differentiation because students will use it when sketching the graphs of cubic functions. We will now watch a video.
Hi, I'm Ivan Mapaling. Let us do factor and remainder theorem.
Subject Outcome 2.1, Factor and Remainder Theorem Learning Outcomes. Factor and Remainder Theorem. Let's take a look at Subject Outcome 2.1 and its learning outcomes in more detail. You will find them on page 6 of your subject guidelines. Subject Outcome 2.1. Work with algebraic expressions using the remainder and factor theorems. By the end of Subject Outcome 2.1, your students should be able to use and apply the factor and remainder theorem to find the remainder, prove that an expression is a factor, find an unknown variable to make an expression a factor or to leave a remainder, factorize third-degree polynomials. The combination of factor and remainder theorem and inverse functions is weighted 25% in Paper 1. This is usually broken down as roughly 10% factor and remainder theorem, 15% inverse functions. Learning Outcome 2.1.1. Use and apply the factor and remainder theorems. Pre-knowledge for factor and remainder theorem. Students need to know how to simplify, manipulate, and factorize algebraic expressions, including those with algebraic fractions, and how to solve linear and quadratic equations. To start off this section, It is helpful to check that students understand important terminology in algebra, such as polynomial, which is an expression composed of two or more terms. A term, numbers and variables separated by plus or minus signs. A coefficient, the numerical quantity multiplying any of the variables. Constant, a number or a letter representing a fixed number. And the degree of a polynomial, which refers to the highest power of the variable. Students should be able to identify when an algebraic expression is not a polynomial. The powers of the variables of a polynomial must all be positive whole numbers. Remind students of the link between factors and roots. Factorizing a polynomial allows you to find the roots, or x-intercepts of the polynomial. For example, this quadratic polynomial, x squared plus 2x minus 8 is factorized to two linear factors, x plus 4 and x minus 2. These two factors are then set to 0 to find the two roots, x equals negative 4 and x equals 2. Remind students, when they are working with a polynomial, they should make sure that it is written in descending powers of the variable. Remember, third-degree polynomials are also called cubic polynomials. Second-degree polynomials are also called quadratic polynomials, and first-degree polynomials are called linear polynomials. Let's take a look at the remainder theorem. The remainder theorem gives us a quick way to work out the remainder when a polynomial of higher degree is divided by a linear polynomial. It states that if a polynomial f of x is divided by a linear polynomial g of x equals ax plus b, then the remainder is equal to the value of the function at negative b divided by a. In other words, we simply need to substitute negative b divided by a into the function and simplify. Take note that the remainder theorem only works for linear divisors. Teaching tip on the remainder theorem. The value of negative b divided by a is obtained by letting the divisor equal 0 and solving for x. Students should be used to doing this when they solve linear equations. Let's look at an example. Use the remainder theorem to find the remainder when the polynomial x cubed plus 2x squared plus 3x minus 6 is divided by x minus 1. First, we find the value of negative b divided by a by letting x minus 1 equals 0. Therefore, x equals 1. Now, substitute 1 for x into the polynomial. Simplify. The result is 0. Hence, our remainder is 0. Try this example on your own, and then we will watch how a lecturer applies the remainder theorem to find the solution. Use the remainder theorem to calculate the remainder 2x cubed plus 2x squared minus a minus 12x a squared plus 6a cubed all over x plus 3a. Let's have a look at the solution.
Applying the remainder theorem, you are given 2x cubed plus 2x squared minus a minus 12x squared plus 6a cubed all over x plus 3a. To begin with, let's focus at our denominator. You are given a denominator of x plus 3a. We must factor this to be equal to 0. We therefore have to find x. This clearly makes it easy for us to see that x must be equal to minus 3a. We're therefore going to substitute that into our numerator. Now, where we see x, we substitute minus 3a. First step, we have substituted minus 3a in the place of x. Then we're gonna multiply. Now, we're gonna need to be very careful with one thing here. What we must understand here is that you will only work out of the bracket, then multiply. Work out of the bracket, then multiply, which therefore makes it so minus 3 cubed is going to be equal to minus 27. Of course, it's 27a. 27a times 2 makes it minus 54. So minus 54a. It's just this part. Which is positive 18a. Bring down the minus a. Then what you must do here, first open the bracket with this, then multiply with 12. So you will see that to multiply in terms of the same basis, you add your exponents. So it's going to be minus 3 times minus 12, which is positive 3 times 12, 36. So it's going to be 36 a to the power 3 plus 6a to the power 3. Now we're going to have to collect our like terms. So let's look for the like terms. Let's look for the like terms. So we're going to follow up these ones, put them next to each other. What I always suggest is that your like terms must follow each other. So we're going to work these ones out. You can easily say minus 54 plus 36 plus 6. Your answer is going to be equal to minus 12a cubed. The cubes, the power 3's are done, plus 18a squared minus a. That is your final answer.
The remainder theorem leads directly to the factor theorem because if we find that the remainder is 0, it means that the divisor is actually a factor of the dividend. The factor theorem states, if f of x is a polynomial such that f of negative b divided by a equals 0, then ax plus b is a factor of f of x. Now we have a method to check whether a linear polynomial is a factor of a polynomial. This is clearly very useful for factorizing polynomials. Let's look at an example. You are given the polynomial f of x equals x cubed minus 3x squared plus 4x minus 12. Use the factor theorem to find out whether the following are factors. 1. G of x equals x minus 3, and 2. H of x equals x plus 4. Number 1. We need to find negative b divided by a for the polynomial x minus 3. Do this by setting x minus 3 equal to 0 and solving for x. The result is 3. Now, substitute 3 into the polynomial f of x. The answer is 0. This means that the remainder is 0, so g of x is a factor of f of x. Number 2. Find negative b divided by a for the polynomial x plus 4. Do this by setting the x plus 4 equal to 0 and solving for x. The result is negative 4. Now substitute negative 4 into the polynomial f of x. We get a remainder of negative 140. So h of x is not a factor of f of x. We asked the lecturer for his thoughts and some tips for teaching the factor and remainder theorem.
Hey, this is a problem. Because the learners don't read. The first keyword in that question is prove that it is a factor. What does that mean? Substitute that value equated to 0. And when it meets that requirement, then it is a factor. Closely linked to that, if you don't get a value other than 0 immediately, that is a remainder because that value indicates a remainder. The other thing is they mix it up, function of x, then they got a variable there. Here you must also read. Then they tell you it is a factor, but they give a value. When you substitute that value, function of 3 equals to the function of 3. By mentioning it, it is a factor that you substitute with 0. And then you get a very simple linear expression where you can find the variable. But now, the one that they ask lately in the exams is where you need to find 2 variables, and now comes the problem. 2 variables, let's use logics. Basic logic in mathematics. 2 variables, 2 equations, 2 factors. In other words, everything got to do with 2. Now, how will you get 2 factors? They will give you a quadratic trinomial. When you factorize that, then you get 2 factors. And then you substitute the first factor to get your first equation. You substitute the second value to get your second equation. And the rest is baboon tricks because you sit with 2 basic simultaneous equations and you solve it.
Try this example on your own. Prove that open brackets x plus 3 close brackets open brackets x minus 4 close brackets is a factor of x cubed minus 7x squared minus 6x plus 72. Let's watch a lecturer working through the solution.
In this question, we want to prove whether x plus 3 or x minus 4, whether they are factors of x cubed minus 7x squared minus 6x plus 72. Right, now to start off, let's quickly look at x plus 3. Just equate that to 0 and let's get the x value. So x will be equal to, we take this over, right, and it will become negative 3. So wherever we see x, we will now use negative 3. Okay, let's do the other one as well. We have x minus 4 and we equate it to 0, so that will be x will be equal to, and we take that over, so it becomes x will be equal to 4. Okay, I think now that we've done that, we can look at the equation itself, and we can now let's first write this down. We have f of x, which will be equal to x cubed minus 7x squared minus 6x plus 72. Right, now if we are going to substitute x, let's say this will be f, and we substitute the x with 3. We're going to start with 3. So in the place of x, we will substitute it with 3. So now we will have is equal to, you've got an x, so this will be, we'll just put that brackets to show that we have substituted over the cube. And then we have minus 7, substitute the x with 3, and it will be squared. And then we have minus 6, substitute the x with 3, and then we have plus 72. Okay, this will be equal to, right, so we have the first number will be, we have, yeah, I can see what I did wrong here. So this was supposed to be a negative. I was thinking what's wrong here, what's happening, that's negative. We have to be careful with that, né? Okay, so if that is negative, our answer will then be negative 27, and the next answer will be negative, is that true, negative, yeah, negative 63, and then we will have plus 18, right, that's correct, plus 72. If we add them all up, right, add them up, and it will be equal to 0. Now, we know that if there's no remainder and it is 0, we can say, yes, this is a factor of the expression right here. Okay, so we can agree that that's that x plus 3 is a factor. Let's make that number 1, and let's do the other one. Let's see if, let's look at x minus 4, whether that is a factor. Okay, we've already worked it out, so we can say we have f of x once again, and we have x, which is equal to x cubed minus 7x squared minus 6x plus 72. And now we are going to substitute x with 4, and it's a positive 4. Yes, it's a positive 4. So we're going to say, okay, wherever we see x, that will be 4 cubed minus 7, and it will be 4, right, squared, and this will be minus 6, and substitute the 4, the x and the 4, that will be 4, and it will be plus 72. Okay, so that will be equal to what? I think this is correct. It is 64, and then we have, let me see, minus 112, and then we have minus 24, and then we have plus 72. Okay, let's add them up. Let's add them up, and it will give us equal to, it's equal to 0. So once again, there's no remainder, so this will also x minus 4 will also be a factor because there's no remainder. Now, that's normally how we do it. That's normally how we do it. Let me just show you. Let's just look at another way in which one can do this. Okay, so we have the factor minus 3. This is called a synthetic method. Okay, right. Look at the coefficient. We're going to use the coefficient of the expression. So the coefficient is 1 minus 7 minus 6 plus 72. Okay, for the first one, we leave the first one with 0. We add up. 1 plus 0 will give me 1. Now the fun starts. We say negative 3 times 1 will give me what? Negative 3. Add it up. This will give me negative 10. Right, now look at this. Negative and negative will give me positive. Good. 3 times 10 will give me 30. Add these two up, it will give me plus 24. Okay, negative and negative will give me, negative and positive will give me negative. Negative 3 times that positive 24 will give me the negative 72. If you add it up, it will be 0. And what are we after? 0. So we can say, yes, it is a factor. Yes, it is a factor because there's no remainder. Okay, that's called the synthetic method. I find that students like this and they use it, but well, it's up to you as lecturers to choose what you want to. We have 4, right? And once again, we have 1 minus 7 minus 6 plus 72. The expression is most the same. So now make this 0, and 1 plus 0 will give me 1. This is positive. Positive 4 times 1 will give me 4. It is positive 4. What do I have here? If I add it up, I'm going to get negative 3. Am I correct? Yes. Let me just check it again. That's 4. It's positive. Subtract that. Okay. So the next one would be, let's look at this. This is negative. Negative and positive will give me negative. Right. And it's a negative, and 4 times 3 would give me 12. What do I have? 18. Negative 18. So, beautiful. 4 times negative 18 will give me negative 72. And yes, you can see these two are going to cancel out and it will be 0. Yes, there's no remainder. No remainder. And if there's no remainder, it will be a factor.
Let's try a more difficult example using the factor and remainder theorems to find unknown variables. Examiners really like this type of question. Please work in pairs. Discuss how you would approach the question and then try to solve the problem. Let's have a look at a lecturer working through the solution.
This is a question that relates to factor and remainder theorem, which reads as follows. If p squared plus p minus 2 is a factor of the function of p equals to p to the power 4 minus mp to the power 3 minus 5p to the power 2 plus 8p minus n. Calculate the values of m and n. Now it's very important, first of all, to understand this question. The question is that we need to find the values of two variables. And in order to find the values of two variables, we need two equations so that we can solve these two values simultaneously. So, in other words, that's our way of thinking. I need to get two equations in terms of m and n before I can find the value of m and n. How will I get that two equations? Now look here, the factor, it's a quadratic trinomial, which means this tells me that p will have two values. And if I substitute each one of these values into the f of p equation, obviously, then I will get my two equations, and by means of that, I will be able to find the value of m and the value of n. So let's start first by getting our two values. How will we do that? Let's factorize that factor. P squared plus p minus 2 is equal to 0. I need to factorize now. Obviously, this is p and this is p. I need a positive 1, so that will be positive 2, and that will be negative 1. And let's test it. A negative and a positive gives me a negative. And now, 0 product rule. P minus 1 is equal to 0, or P plus 2 is equal to 0. Therefore, P1 is equal to 1 and P2 is equal to negative 2. And those are the values of P. Now, stating that it's a factor, it means that when the value of P is 1, that expression there should be equal to 0, because that is the condition for a factor. So I'm going to first now take P1 and I'm going to substitute it in there in order to get my first equation in terms of m and n. And then I'm going to substitute the value of P2 into that equation, equate it to 0 to get my second equation in terms of m and n. And then the rest is simultaneous equations. So let's find first, all right, the function where P is 1. It's equal, now I'm just going to substitute. That's 1 to the power 4 minus, obviously first substitute, 1 to the power 3m minus 5, P is 1 to the power 2, and obviously plus 8, 1 minus n. This function of x here, function where P, not x, P is equal to 1 is 0. In other words, this whole thing here should be equal to 0. And I will now just do a swap. We're going to say now, you're going to get there 1, that's 0 almost there, minus m minus 5 plus 8 minus n. And our first equation here will be, obviously you can see there, 0 minus m minus n. And then obviously that is 9 minus 5, that is equal to 4. Obviously plus 4. So if I arrange it in a better form, let's move it over, m, right? Move the n also over, plus n, it is equal to 4. And that will be equation number 1. Now the second one, where we substitute the second value. The function where P is negative 2 is equal to, again there, negative 2 to the power 4, obviously minus negative 2 to the power 3m minus 5 negative 2 to the power 2 plus 8 negative 2 minus n. 0, because it is a factor, that's why it's 0. That is 16, because negative 2, negative 2, negative 2, negative 2, that's 4 negatives, that gives you a positive. Minus, obviously, this will be minus 8 m. This will be, that gives me a plus 4 minus 20. That's going to be minus 16 minus n. And obviously, my second equation here, that's most now 0. That's going to be plus 8m. You can see the 8m. Because a minus and a minus gives you a plus. And then obviously minus n. And then here, plus 16 and minus 16, minus 20. And then obviously, what will I get as my second equation here? It is already positive there, so keep it. 8m minus n, and then I move the 20 now over, is equal to positive 20, and that is equation number 2. Now I'm having my two equations, which means I can solve m and n. Let's move to the other side. Equation number 1, simultaneously, m plus n is equal to 4. Equation number 2, 8m minus n, that is equal to 20. And now, what's happening here? The coefficients of n's are the same and the signs differ. So I'm going to add equation 1 to equation number 2. And what will you get there? 1m plus 8m, that gives you 9m. And that is equal to 24. Therefore, m is equal to 24 over 9. And if you simplify that, 3 goes in there 8 times, 3 goes in 9 3 times. And that's the value of m. Then from equation number 1, I can now find the value of n. m plus n, that is equation number 1, is equal to 4. That implies that n is equal to 4 minus m. And now I'm going to substitute. It's 4 minus 8 over 3. And obviously your answer there for n will be equal to 4 over 3. And that's the values of m and n. That we answer the question. Calculate the values of m. m is equal to 8 over 3. Calculate the values of n. n is equal to 4 over 3. So we have answered the question.